Hi friends, welcome back to our channel Physics Tutorial. This is our part 10 video of electric charges and fields. So if you have not watched till part 9, please watch it before going ahead with part 10. Okay. In this video we are going to discuss very important topic, that is Gauss's law. And before going to Gauss's law, we have to know what is electric flux. Okay, we can just see that what is electric flux, then it will be easy to understand Gauss's law. Now, electric flux is actually the measure of total number of electric lines of force passing through that area. So, we can say that number of field lines passing normal through a surface is called electric flux. Okay, so for finding electric flux, that is phi, we can use the equation EA cos theta or E dot ds. So for finding the electric flux, we have to find the number of electric lines of force passing normally through that area. Okay, so we can use the equation phi is equal to EA cos theta, or we can represent it as delta phi, or d phi is equal to E dot ds or E ds cos theta. Otherwise, we can use E dot delta s also. Okay. Clear? That is the number of field lines passing normally through a surface. E dot ds, that is equal to phi. Now we can start with Gauss's law. And first of all, we have to study the definition and proof of Gauss's law. Also, we have some applications of Gauss's law. All these things are very important. And now we can see what is the definition. Right. So, Gauss's theorem states that the total electric flux over a closed surface is 1 by epsilon 0 times the total charge enclosed by the surface. Okay, that means according to Gauss's theorem, the total electric flux that we have found, that total electric flux means the total number of lines of force passing through that area, that will be equal to 1 by epsilon 0 times total charge enclosed by the surface. So here we have to always consider a closed surface, and this law gives the relation between the charge and flux. So it is more fundamental than Coulomb's law. Okay, so we have to understand that the total flux, that is phi, will be equal to 1 by epsilon 0 q, or we can write it as integral E dot ds is equal to 1 by epsilon 0 into q. That is, the total flux is equal to 1 by epsilon 0 times the total charge enclosed by the surface. Okay. Now we have to prove Gauss's law. Okay, for that we are considering a charge plus q, and which is kept inside a sphere of radius small letter r. Here we can see the direction of ds and E. Right, P is a point inside the sphere, and here we have to find the electric flux at P. Okay, for that how we can find electric flux? Here we have to find the electric flux at P. Right, so what will be the electric flux? What is the equation? Yes, that is phi is equal to integral E ds. Phi is equal to integral E ds. Here E is the electric field at P. Okay, so first of all we have to find out electric field at P. So what will be electric field at P? That will be 1 by 4 pi epsilon 0 q by r square. Okay, so that we can substitute here. So how we can find flux? That is E into ds is equal to, instead of E we can substitute the value 1 by 4 pi epsilon 0 q by r square into ds. Right. Now we can integrate on both sides, then only we will get the total electric flux. Okay, so integral E ds is equal to 1 by 4 pi epsilon 0 q by r square integral ds. Right, now integral ds is 4 pi r square. Right, when we are taking the whole surface, so that will be 4 pi r square. Then what we will get? 1 by 4 pi epsilon 0 q by r square into 4 pi r square. Then 4 pi r square and 4 pi r square will get cancelled. Then what is remaining? Integral E ds is equal to 1 by epsilon 0 q. Right, that is the proof. Clear? Now we can go through some features of Gauss's law. The first one is Gauss's law is true for any closed surface irrespective of the size and shape. That is, for any size or any shape we can apply Gauss's law, but the only condition is that that should be a closed. The next one is that the charge includes sum of all charges enclosed by the surface. So when we calculate the total charge, we have to take all the charges. That means we can add it together to get the total charge. The next one is Gauss's law is useful to calculate electric field when the system has some symmetry. So we can calculate the electric field by using Gauss's law, but it should have some symmetry. And another point is that Gauss's law is based on inverse square dependence on distance contained in the Coulomb's law. That means here we are using electric field, right? So that depends on the inverse square law. So that is why it is based on inverse square dependence on distance. Clear? So all these factors that you have to remember, that means the Gauss's law is very important, and remember the definition, proof, and all these features also. Okay, hope it is clear to you. If you like my video, please like, share and subscribe. Thanks for watching.